Okay, our last lesson, 2.6. These are applications of rational expressions and rational equations. There's four main types. So the first type we're going to look at is rate of work. Then we've got motion, which are speed, distance, and time questions. So you're probably used to that, a little bit of science. Then we've got measurement and missing dimensions, so volume, area, those kinds of things. And then we've got money questions, what goes on with money. Okay, so our first one, we've got a couple friends, they're sharing a paper route. Tammy can deliver papers in 40 minutes, and Colin can deliver the same route in 50 minutes. Given the equation below, show the time it takes to work together to complete the route. So whenever you get an equation, they're going to give you an equation, okay? You're not going to have to create the equation. The only ones they're going to expect you to be able to figure out is the ones that you have to match. So they'll give you a word problem like this, and then they might have A, B, C, D, which one matches it, okay? So, for rate of work questions, they are always following the same format. So, on top is what you call time together. The 1 represents getting the complete job done. Okay, that's why it's a 1. You're getting the complete job done. Okay, so you'll always have time together on top. The 1 represents getting the complete job done. Okay, one job, that's like a 1. The numbers on the bottom. So, numbers on the bottom. They will always represent individual time. So, for this question, we have time together. We don't know how long it's going to take them to do it together, but we know individually how long it takes everybody. So Tammy takes 40 minutes, and then we got Colin that takes 50 minutes. The top is doing it together. We don't know how long it's going to take them to do it together. So our common denominator here is going to be 40 times 50, okay? Or just 4 times 50. Okay, or 5 times 40. So the common denominator between the two of those wouldn't be 2,000, it would be 200. Okay, so common denominator is always our first step. Has everybody written down the blue here on the left I can erase? Yeah, okay. Just need to get rid of that so I have some space. So what we've got is 200 for our bottom. So I'm going to have something over 200 plus something over 200 equals 200 over 200. This is the part that's important. Okay? Whenever you find your common denominator, you make the 1 on the right become that number over itself. Always, always. Okay? So these over here are the denominator. That's the common. It's not the one, lady. Just the little head up in there. That's all the video. Okay. Anyways. Yes. You could use 2,000, but it's large. You want the lowest common denominator. Okay. We would just have 2 larger numbers to work with. Okay. So now what we do is the whatever with the 40 would multiply to get to 200. That's what we're going to multiply the top to. So I don't like using with the letter T very often. So they use T a lot, but T looks like a plus sign to me. So I'm going to change it to an X. So that is now X on top. So on the top left here, 40 needs to multiply by 5 to become 200 on the bottom. So I would multiply by 5 to the top. On the right-hand side, 50 multiplies by 4 to get 200. So I multiply 4 by the X. Now we're going to remove the bottom. Okay? The minute you have your common denominators, you clear fractions. Do we have a variable on the bottom? No. So there's no non-permissibles. Okay? So we say T, ER. T can be anything. Now, problem solving, is this actually true? For problem solving, it's not true. We don't use negative numbers for problem solving. There's no negative time for them. So what we would do is, instead of TER, T has to be a positive number. So we need to say, instead of TER, it's going to be T must be greater than 0. That's the restriction here. Okay, and it's always going to be that way because they have to be a positive answer. Okay? All right, now the bottom's gone. We're going to collect like terms on top. We're going to get 9x equals 200, and we literally divide by 9. So x is going to be 22.2 repeating. So that means it takes them 22.2 minutes to do the job together, to do the paper route. Okay? So just over half of Tammy's time. Okay, any questions on that? Yeah? It's got to be bigger than 0. Yeah, because we're finding a solution to something. Okay? All right, let's take a look at the next two. Now the next one right here, this guy has x on the top. Okay? We're going to work together to create a common denominator, and then I'm going to give you a couple minutes. I want you guys to solve this one. So, we've got Alex can mow his lawn in 45 minutes. His little brother Frank can mow the same lawn in 1.5 hours. You're going to notice the time frame is different. So we need to change the time frames to the same, and they're asking us in minutes. So that's how we know to change the hours to minutes. So we're going to go 1.5 hours equals 90 minutes. That's where this 90 came from. Okay? So we've got Alex and we've got Frank. Okay? Alex and Frank. So what will be our common denominator between 45 and 90? 90, exactly, because 45 times 2 is 90. So, our common denominator turns into this. Something over 90 plus x over 90 equals 90 over 90. Okay, we're going to notice that the guy here, Frank, x over 90 didn't have to change because he already had a 90 on the bottom. So the guy on the left-hand side, Alex there, we have to multiply his number by 2. Because 45 times 2 will give us our common denominator. So on top, he's going to have a 2x. Do we have any non-permissibles? Any variables in the bottom? No. So, how are we going to say for this? We use x for this one. So what are we going to say about x? Plus be greater than 0. Perfect. Okay? Greater than 0. Get rid of our bottom. Okay? Once you convert your bottoms and tops, your bottoms are gone. Now we're going to add like terms on top. We have 2x and 1x. That's going to give us 3x's equal 90. Now we're going to divide out the 3. And we are going to get x equals 30. So it takes them 30 minutes to mow the lawn together. Okay? 30 minutes. Now number 3 is a little different. And this is where you're going to see some of them like these ones. So Harold's apprentice takes 9 hours longer to build a deck than it takes Harold, an experienced carpenter. So it says when they work together, they can build it in 20 hours. How long does it take each person to build that deck? So what we've got is our equation given for us. So the time together, we know it takes 20 hours to build the deck together. All right, so we have Harold and we have his apprentice. Okay, because his apprentice takes longer, so he's the plus 9. So now we're going to find a common denominator. Here we've got a binomial, and here we have a monomial. They are different, so we need both of them. So that means we need the x and the x plus 9. So we would do this. X plus 9, plus x plus 9, equals x plus 9, all over itself, x plus 9. So we have to show that we're creating a common denominator. Okay? The 1 on the right-hand side creates the common denominator on top and bottom. Okay, I'll let you get caught up there. At this point, yeah.
Is this like what we were doing in the last unit or lesson where we were like finding the common denominator?
Yeah, yeah. Yeah, exactly. Every word problem has to be x greater than 0, and it's got to be these. So here we're saying it's greater than 0, but what's the non-permissible on just x? Just 0. What's the non-permissible here? -9. So yes, x has to be greater than 0, but he can't be equal to 0, and he can't be a -9. And part of the reason he can't be a -9 isn't just because of the non-permissible, it's because it's a problem-solving question. Okay, we can't have 0 or a negative number. It has to be larger. Okay? All right, so now we're going to look and see what is missing on the bottom left-hand side for my common denominator. I only have an x, and I need both of them. So what do I need to add to the top? X plus 9. So I'm going to have a 20 on the outside of brackets, and x plus 9 in brackets. Okay? On the right-hand side, what's it missing? Just the x. So we're going to have 20 and an x. Okay? Now that we've done non-permissibles, we can erase the bottom. So the bottom is now gone. So I'm literally going to grab the eraser. Is everybody okay with that? Alrighty. Okay, we're getting rid of that bottom. There it goes. Bye-bye. Okay. Now we've got to get rid of brackets. So we're going to multiply into both set of brackets that we see. Okay? So that's going to give us 20x plus 180 plus another 20x's equals x squared plus 9x. Now, we have to look and see if we've got an x squared on both sides. We don't. So what we have to do is see if x squared is positive where he is. Is x squared positive where he sits? Yes. So that means we're going to bring everything else from the other side to his side. So that means all of this is going to the right. But we're going to add these x's first. So I can add those x's together first. So I have 40 x's I'm moving over. So they're both positive, so I'm going to subtract 40x. So I'm going to subtract 40x to the guy that has the x. Okay, you can't subtract them to anybody else. It has to be the guy that has the x. That's how we match them. Okay? Then we're going to bring the 180 over. He's going to become a negative 180. So minus 180 minus 40x on that side. So here's our minus 40x. Now I got to go minus 180. Okay? Yeah. So now all we got to do is we got to add like terms on each side. So if I add like terms on the left, everything is gone. It disappears. On the right-hand side, I've got to add the 9 and the negative 40. That's going to give me a negative 31. So now what I have is x squared minus 31x minus 180 equals 0. And now we would do the diamond on that. Or if you like the quadratic formula, because these are big numbers, that's fine too. Okay. Just going to move it up for you so you can see it a little better. Okay. So if I do the diamond on this guy, I need a negative 180 and a negative 31. Well, let's do a factor chart for 180. What sign is the middle number? Negative. The sign in the middle tells you that the big number will take his sign when you're factoring. So that means right here, negative 31. So all my big numbers will be negative. So 1 times negative 180. 2 times negative 90. 3 times negative 60. And we keep going. 4, does 4 go in? 4 times 45. Negative 45, that is. And then there's 5 times negative 36. And that's the one we're looking for, because that's going to give us negative 31. So we're looking for that guy right there. So those are the numbers that are going to go in the brackets. So I open my 2 brackets. I end up with x plus 5, and an x subtract 36. Now remember, those aren't my answers. I have to remove them from the brackets. So that's basically the same thing as doing a non-permissible, but we're actually solving for x. We're saying what x can be. So, what can x be in that one? And again, it's opposite signs, same idea. Okay, x equals -5 there. Are we allowed it? No, so that's not part of a solution, because negative values are not allowed in problem solving. Okay, next guy, what should he be then? Positive 36. That's our answer. So now we know how long it takes Harold. So it takes Harold 36 hours to build that deck, and it would take his apprentice, it would take him 36 plus 9, which is 45 hours. Okay? Now, typically, this is a great numeric response question. They might say to you, place Harold in the first 2 boxes and place his apprentice in the last 2 boxes. So you would write 3, 6, 4, 5. That's how you would record that if that's what they wanted in the numeric response. Okay, so you put Harold first, then his apprentice. Okay? All right, now we're going to jump into some motion questions. Distance, speed, and time. Yeah. Okay, let's give you a minute to finish writing that down. So motion is the speed, distance, and time. Sometimes speed is called velocity. So in your physics classes, you might have heard it called D versus S. So distance, speed, time, distance, velocity, time. You might also see it being called rate of speed. So they might use an R, okay, just so you know. So rate of speed or velocity, okay, they might use, but it just means how fast they're going. So we always are going to be creating a time equation. So in order to create a time equation, we're always going to have distance on top of speed. Always, always. So what we got here, whenever we've got an equation, we need to let x represent something. So we have to kind of make a legend. So here, we're going to let x be how fast Jerome's going to row his boat. So let's read what we got here. Jerome rows his boat 24 kilometers downstream and then back to where he started. Then it says, when the average speed of the current is 2 kilometers, Jerome completes his entire trip in 9 hours. Given the equation, how fast does he row his boat? So, this is upstream, this is downstream. Okay, so we've got upstream and we've got downstream. So I'm going to show you how they've actually created the equation. Because sometimes they're going to give you a table. And they're going to say, this is how, or what numbers would match the equation. Okay, which table would match. So the way they set it up is like this. So, upstream, downstream. Okay? Then they've got distance, speed, time. Okay? So, he goes 24 kilometers both ways. Okay? That's why they're both 24. His speed, well, if you go upstream, you're going against the current. So is that faster or slower? Slower, good. So since upstream is slower, it's going to be the x minus 2. Okay? Yes, dear. Yeah. Okay. Then we're going to do downstream. Downstream goes faster, so we're going to take the speed that he rows his boat and add the current. So it's going to be x plus 2 because he's going faster downstream. Time is just the distance divided by speed. So they're going to take 24 over the x minus 2, 24 over the x plus 2, which is where they end up with our equation. Okay? But they will show you tables of values like this. They're going to show you a worked out table. And they may say which one matches the equation A, B, C, D. Okay? So the equation, just so you know, will always come from this. Always from the time. Okay? Because they're always finding out how something about time because we're solving for speed. Alright. So, we have a common denominator. We need both of those because they're different. Whenever they're different, we take both. So, am I allowed to raise this bit? Yeah? Okay. So, common denominator is going to be both of them. X plus 2, x minus 2. X plus 2, x minus 2 equals x plus 2, x minus 2, I'm running out of room, x plus 2, x minus 2. Okay. Okay, so that's what we get. Now we're going to put the numbers up there that they gave us. Okay? So they gave us a 24, a 24, and a 9. Okay? So now we've got to figure out what is missing on the top of each. So what's missing on the top of the first one? X subtract 2. What's missing on the second one? X plus 2. Okay? What are the non-permissible values? X cannot be plus and minus 2. All right. What is the restriction? X has to be greater than 0. Okay. Now we can get rid of the bottom. Are we okay if I wipe the bottom off? All right. Here goes the bottom. Okay. So what we're doing now is we're going to multiply into the brackets. Does everybody understand that this is a difference of squares that was factored? Whenever they're identical but opposite signs, whenever you multiply them, it'll give you a difference of squares. So if I were to FOIL this, that's giving me x squared minus 4. Because if we square root x squared, we get x and x. Square root 4, we get 2 and 2. Separate with plus minus. Okay, are we okay with that? Alright, so I'm going to put the x squared minus 4 beside the 9. Because that's where he belongs. So I would FOIL this, because you have to do bedmaths. So you would multiply these, do FOIL or an area box. Okay, which gives us this. X squared minus 4, that's what it gives us. Okay, so that's what I'm putting in front of the 9 now. Okay, and now I'm going to multiply those guys in the brackets. And I'm going to get 24x minus 48 plus 24x plus 48. So that's what I get on the left-hand side. I'm right click. Where's my right click? I need to move him down. Make more room. Okay. Okay, so we're going to now add like terms on the left. So I'm going to add my 24x and my 24x, which is going to give me 48x. What do you notice about the negative 48 and positive 48?
They cancel out.
They cancel out. All right, they cancel. So we get 48x equals 9x squared minus 36. Now I need to move the 48x to the right. We always want to go to where x squared is positive. He's positive on the right, so we're moving this guy in between them because we want the x in between. Okay, so he's a positive 48 on the left. He'll become a negative 48. So we're going to have 9x squared minus 48x minus 36 equals 0. Let's see. Okay. Now, if we were to diamond factor this, we would diamond factor this, and it's going to give us a perfect square trinomial. That's what it's going to give us. So, we end up with, am I allowed to move it up? We could take a GCF of 3 out, yeah, absolutely, that's probably what we should do first. So, we would divide 3 out, and get 3x squared minus 16x minus 12 equals 0. Now our diamond is going to be more reasonable. So 3 gives us a negative 36 and a negative 16. Okay? So our brackets will become okay, this is what we're doing right now. We need to get our numbers for the wings. So when we factor 36, I'm just going to erase a little bit of this on the left so I can factor 36. So negative 36, what's the sign of the bottom guy? Negative, so that means the big numbers are negative. So 1 times negative 36, 2 times negative 18. Did I find my numbers? Yep, 2 and negative 18. You can stop when you find your numbers. So I found 2 and negative 18. Now we have to see which one will divide by 3. Why am I talking about dividing by 3? Because there's a 3x exactly in front of the brackets. So, or sorry, not in front of the brackets, but in one bracket. Yes? Because you have to multiply A times C. And A was 3, C was negative 12. Okay? All right. So now we're going to divide this guy by 3. So we're going to get a negative 6 plus 2. So now we have, with this, 3x plus 2, x minus 6 equals 0. With this one, we're going to get a negative answer coming out. Can I have a negative answer? No, so I'm not going to worry about that bracket. I'm going to worry about the bracket with a positive answer coming out. So a negative is going to come out as a positive. So that's going to be x equals 6. Was that part of my non-permissible? Nope, so that's a possible solution. So now we know that Jerome Road is about 6 kilometers an hour. Okay, so that's what it gave us, 6 kilometers an hour. And with the current, you add 2 or you subtract 2, depending on whether you're going upstream or downstream. Okay, so that's what that one's talking about. All right, everybody has this cycling one underneath it. The cycling club is done almost identical. So I will give you the answer to the cycling club, and you guys can figure that one out on your own. So we end up with x equaling 9.9 or 10. Okay, they do want it to the nearest tenth, so that's why it's 9.9. You're going to end up with this, 4x squared minus 22x minus 175 equals 0. Because you get a decimal answer, it won't diamond. This one will not diamond. So you have to use the quadratic formula on this one to solve it. Okay? So this guy is your A, this guy's your B, this guy's your C. Make sure you get this for that. Once you do the quadratic formula, remember you only want the positive answer. The answer you'll get is that. Okay? So I'll let you guys work that question out on your own. And we're going to move on to the next question, which is Toronto to Vancouver. The flight Toronto to Vancouver. So on this one, same idea. All they want is an expression. There is no equal sign on this. So all they want is you to create a common denominator, which you have to keep. Okay? So on this question, what would be our common denominator on that one? X and x plus 100. They're different. You have to use them both. So whenever they're together on the bottom, they're considered a binomial. So that's a pair. They go as a pair. So now I need both of them. So my common denominator would be x plus 100. X plus 100. Okay, that's my common denominator. We're going to multiply to the top the part that was missing. So what's missing on the left-hand side? The x plus 100. Okay? And on the right-hand side, what's missing? Just the x. Now we put the numbers they gave us, 3,400 and 3,400. All we need to do is multiply that guy into the bracket, and then we're going to add like terms on top. Again, there's no equal sign for this question, so they don't want us to solve it. They want us to create just an expression. So, this is going to give us 3400x plus 3400x. Because this guy's going to be a 3400x, so we have to add them together. So we're going to get 6800x plus 340,000 all over x plus 1. Okay, that's all it is. And then we put our non-permissibles. X cannot be 0 or negative 100, and then we put the restriction. X has to be greater than 0. Okay? And that's all. We can't solve that one. They did not give us a time frame. If they said they did both of these flights in 18 hours, it would be equals 18 over 18. Okay? Good to go? Or sorry, 18 over 1, not 18 over 18. All right. This is an upstream downstream, where upstream is equal to downstream. So you're going to see how they created a chart for this one. And this is why we're going to use charts. So sometimes they put information in a chart, like I said before, and they ask you to match it to different equations. So we need to be able to place the information in the chart. So, first one here. Says the boat is traveling at an average speed of 15 in still water. So x is equal to the speed of the current. 15 is still water. Then it says the boat travels 12 kilometers downstream. So now we know this is 12. That's downstream. In the same time that it travels 8 kilometers upstream. So we have equal time. If they're equal time, that means one equation will equal the other, which is this. Upstream equals downstream. That's what we're going to end up with an equation. So the speed, well, going upstream, we are going faster. So we would subtract the current. So minus x. Or sorry, we add the current, but we're minusing still water. Here, 15 plus x, because downstream is much faster, we would add the current. Okay? When you're upstream, you're going against the current, it's much slower. Okay? The time frame is just distance over speed. So this guy now is going to be 8 over 15 subtract x, and here is 12 over 15 plus x. And now you've got one equation equaling the other. Upstream, 8 over 15 minus x, equaling downstream, 12 over 15 plus x. So that's how we would set it up to start. Okay, from this point we do our non-permissibles. We say x cannot equal plus and minus 15, and the restriction, he must be greater than 0. That's its problem solved. So what would you consider the common denominator?
15 plus x, 15 plus x.
That's right, both equations. You need both brackets. Remember, they're not going to show you that these belong in brackets, but they're a binomial pair, so they go together as a pair. So you need both of them. So that means basically you're cross-multiplying. That guy's going to multiply to the top, and then cross the other guy's going to multiply to that top. This is the only time that cross-multiply kind of works. And it's because you're multiplying what they're missing. So, do we need to keep a bottom when we have an equation? Nope, with an equal sign we get rid of the bottom. So I just need to multiply my tops. So I'm going to have 8 times 15 plus x equals 12 times 15 minus x. So this is what the equation creates. So now when we multiply it into the brackets, we have to multiply in to get rid of everything. Let's move those guys over. Oh, let's just erase it all. Just need more room. Okay. Oh, darn it. Okay. Let's move this guy over so I can deal with it. Okay. So we're multiplying into the bracket. So 8 times 15 gives us 120 plus 8x. 12 times 15 is going to give us 180 minus 12x. So typically we want to take x to the left and the digits to the right. So I'm going to minus 120, minus 120, and then I'm going to add 12x, add 12x. You always add it underneath the one that it's going to add like terms to. Okay, so you're adding the x to the x and the digit to the digit. Okay? So now when we combine like terms, these guys will disappear on the left. On the right, the x's will disappear. And now we've just got to add the like terms. So we're going to end up with 20x equals 60. We're going to divide out the 20. And how big does that give us? Pretty good. So x is equal to 3. And so remember, what did we find with the x? It was the average speed of the current. So we would say the average speed of the current equals 3 kilometers an hour. Okay. These are the first 2 types of problem solving.